And that was the case today concerning Mount Rainier.
Here in Washington, we have our own volcano threat in the Cascade Mountains, which on average erupts once or twice every century.
Towering over the evergreen forests and vibrant cities of the Pacific Northwest, Mount Rainier is both a beacon of wild beauty and a silent sentinel on the skyline. Ascending 14,411 feet above sea level, its icy peak is visible for miles, a striking reminder of the turbulent forces that shaped the Cascade Range over millions of years. Each year, thousands of adventurers are drawn to its snowy slopes, and millions more gaze up in awe, perhaps never fully aware of the vast energies contained beneath the mountain's tranquil surface. Yet, in recent days, a new murmur has made its way through this ancient landscape. A swarm of hundreds of small earthquakes has rippled beneath Mount Rainier, the largest seismic swarm at the volcano since 2009. Agencies like the U.S. Geological Survey, the Cascades Volcano Observatory, CVO, and the Pacific Northwest Seismic Network, PNSN, are carefully monitoring every subtle movement, every shifting fracture beneath the Earth's crust. Despite this uptick in earthquake activity, the USGS maintains that Mount Rainier's alert level remains at normal. There are no signs of an imminent eruption. Still, scientists acknowledge that the current earthquake activity is unusually high for this well-monitored volcano. What does it all mean? Could Mount Rainier, under the right circumstances, unleash its pent-up force once more? An even more intriguing and perhaps unsettling question lingers. Could an eruption at Rainier trigger a chain reaction across the Cascade Range? How real is the threat that one of America's most iconic volcanoes could set the entire spine of the Northwest trembling? Join us as we untangle the mystery at the heart of the Cascades and explore the dynamic forces that bind these ancient volcanoes together. Are the mountains truly sleeping or simply waiting to awaken? The Cascades, a range forged in fire. Stretching for over 700 miles, the Cascade Range is far more than a dramatic sweep of peaks and glaciers. It is a dynamic chain where geology, history, and destiny are woven together by forces as old as the planet itself. From Northern California's Lassen Peak, through Oregon's legendary Mount Hood and Crater Lake, to Washington's formidable Rainier and the infamous St. Helens, the Cascades stand as testaments to both creation and destruction. This landscape was forged in fire. For millions of years, the slow but relentless grinding and subduction of tectonic plates have produced lines of volcanoes along the Pacific Northwest. As the oceanic Juan de Fuca plate dives beneath the North American continent, molten rock rises through the crust, sometimes erupting explosively, other times building quiet, massive domes. This is a region defined by its volatility, a land in which entire ecosystems have been swept away in fiery eruptions, only to regrow in unexpected forms. Mount Rainier, with its gleaming cloak of snow and ice, seems at first glance a world apart, yet it is intimately connected to its siblings throughout the range, like Mount St. Helens, which erupted spectacularly in 1980, or Mount Hood, stirring with its own geothermal activities. Rainier's story is part of a larger saga. Each volcano holds its secrets and tells its own tale in ash and stone. Some have ancient calderas, others fresh scars, and all are alive with a hidden pulse detectable only by sensitive instruments stretching across the Northwest. When seen from above, the volcanoes of the Cascades form a near-linear chain, a series of sentinels shaped by the same relentless processes. But do they share more than just a common origin? Could these giants, connected by the circumstances of their birth, influence each other in times of unrest? The mere thought is at once mesmerizing and unsettling. Is the awakening of one Cascades volcano destined to quicken the rest? Mount Rainier's recent earthquake swarm, signs and signals. In July 2025, the very foundations of Mount Rainier shuddered in a display of subterranean unrest that drew the eyes of the geological community. Hundreds of micro-earthquakes, far more in number than usual, rattled the rock under the mountain in what scientists call a swarm. For the USGS and its monitoring partners, it was the largest such swarm recorded at Rainier since 2009. But what exactly does all this seismic activity mean? Are these earthquakes warning shots, or simply the mountain's way of tossing and turning in its geological sleep? In reality, earthquake swarms are not particularly rare at Rainier. They may occur once or even twice a year. Most of these swarms, however, are smaller in both number and intensity. Experts say these events most often reflect shifts related to underground water, steam, or gas movement through cracks in the volcano, or occasional readjustments along faults under the mountain. Sometimes, swarms can be connected to the movement of magma, but more often, they are the result of the regular churning beneath an active stratovolcano. Yet, the size of this latest swarm marked it as notable. Instruments deployed by the Pacific Northwest Seismic Network, PNSN, mapped each tremor in real time, allowing rapid updates and responses. Special GPS equipment scanned the surface for signs of swelling or shifting. Gas sensors monitored for changes in volcanic emissions, and satellites peered down to detect any ground deformations invisible from the ground. So far, the results have been reassuring. There are no unusual gas emissions, no visible changes to Rainier's snow-clad slopes, nor evidence of magma pushing closer to the surface. USGS volcanologists stress there is no evidence that Rainier is due for an eruption. The concept of a volcano following a set schedule is a myth. The reality is far more complex. Despite the volume of recent earthquakes, they conclude that the volcano's alert level remains at normal. There is no ash, steam, or new cracking on the mountain. Still, the public's curiosity is understandable. Could a persistent swarm like this be an early sign of deeper changes? History counsels caution, but not alarm. Although increased earthquake activity can sometimes precede eruptions, often it does not. Swarms may be resolved by shifts in underground fluids or by minor structural adjustments. The mountain quiets and the drama disappears, except in databases and scientists' analyses. Yet, in rare cases, an uptick in seismicity is the only warning before an eruption unfolds. For now, it appears we are witnessing a restless mountain, not an awakening giant. But such periods always provide the scientific community a valuable window into the inner workings of volcanoes, reminders that mountains, which appear serene from above, are often alive with change within. Volcanic chains. How connected are the Cascades? The notion of volcanoes erupting in sequence, a literal chain reaction, has long fascinated both laypeople and some researchers. The scenario conjures vivid images, one eruption begetting another, sending shock waves through the entire Cascade spine. But is this actually possible? How deeply are the fates of the Cascade volcanoes linked? The Cascade Range's dramatic alignment suggests a hidden connection. In one sense, all these volcanoes share a common parent: subduction of the Juan de Fuca plate beneath the North American plate. This tectonic process permits magma to rise and over millennia feed the roots of the region's volcanoes. However, recent research and decades of monitoring indicate that the Cascade volcanoes' plumbing systems remain relatively separate. Each major edifice taps its own local reservoir, fed by specific factors unique to that part of the range. These magma chambers are not thought to be joined by vast underground tunnels or rivers of molten rock. Instead, they are separated by thick sections of crust and only weakly connected, if at all, through deep regional stresses or faults. In some rare cases, Elsewhere in the world, geologists have observed that major eruptions can alter pressure conditions to the degree that nearby volcanoes, sharing the same shallow magma system, show signs of unrest. However, in the Cascades, direct evidence of one volcano triggering another from a distance is lacking. For example, following the 1980 Mount St. Helens eruption, nearby volcanoes, including Rainier and Hood, were closely monitored, but none exhibited signs of significant new activity attributable to changes in St. Helens itself. That said, very large regional earthquakes or exceptional tectonic events might theoretically impact more than one volcano in the same general area, perhaps nudging their plumbing in subtle ways. The stress field of the Earth is complex and may produce sympathetic increases in minor seismic activity, but triggering a sequence of major eruptions remains speculative and highly unlikely on any time frame relevant to human society. Can Mount Rainier set off a domino line of Cascades volcanoes? On our current understanding, the answer appears to be no for direct eruption-triggered chain reactions. Still, the entire region lives at the intersection of powerful tectonic forces. Each volcano operates on its own schedule, driven by the accumulation of pressure, magma composition, and a host of unpredictable variables. The fates of the Cascades are related at their roots, but not in any immediate chain reaction sense. Lessons from Cascade history, echoes of eruption. The past is a powerful teacher, and the history of the Cascades is filled with moments of sudden, violent transformation. Perhaps the most searing lesson came in 1980, when Mount St. Helens erupted with a force that shocked even seasoned volcanologists. Earthquake swarms had gradually grown more intense. Steam venting marked the volcanic unrest, and on May 18th, a catastrophic landslide triggered one of the most dramatic lateral blasts in recorded history. Mount St. Helens eruption sent ash 15 miles high, razed forests, and refashioned part of the mountain into a vast crater. In response, the USGS and partner agencies rapidly expanded their monitoring networks across the Cascades, launching a new era of round-the-clock vigilance and public preparedness. This vigilance now extends to Rainier, Hood, and lesser-known peaks across the Northwest. Rainier itself has a powerful but quieter history. Its last major eruption is believed to have occurred about 1,000 years ago, but the volcano has produced significant mud flows, lahars, that have left deposits dozens of miles from the mountain. Some of these were not directly linked to eruptions, but to slope failures and interactions between heat, rock, and ice. What about seismic swarms? Similar swarms have been recorded at Rainier and several other Cascades volcanoes in the past, but these have rarely led directly to eruptions in modern times. The biggest takeaway from events like Mount St. Helens has been the need for continuous, careful monitoring and a clear sense of humility. Seismic activity can be a warning, but not all swarms mean an eruption is imminent. Crucially, the Mount St. Helens eruption did not set off a wave of new eruptions in the neighboring Cascade volcanoes. Scientists monitored the changes in regional seismicity and groundwater, but no true cascade of eruptions occurred. The lesson remains: major eruptions are singular events, though their repercussions may change land, climate, and understanding for decades afterward. Monitoring the giants, science on the edge. As Mount Rainier shudders with new earthquake swarms, a parallel drama unfolds at the interface of science and technology. Through the investments of recent decades, an interwoven network of sensors and scientists stands vigilant across the Cascades. Seismographs are positioned throughout the region, mapping the finest vibrations and charting each earthquake's depth and location. GPS arrays measure surface movement in fractions of an inch. Specialized gas sensors monitor for telltale volcanic emissions, carbon dioxide, sulfur dioxide, and more. Remote sensing, both on the ground and from satellites, tracks changes in temperature and subtle ground deformation. Thanks to these systems, scientists can spot the earliest clues of volcanic unrest, well before any surface changes become apparent. The July 2025 swarm was tracked in real time with rapid interpretation and communication to public safety officials and the community at large. Despite the intensity of recent activity, Rainier's current status does not trigger concern of an immediate eruption. The volcano alert level remains at normal, and there is no indication of a surface event. The high quality of monitoring is itself the legacy of St. Helens and other catastrophic eruptions, the cost of hindsight paid forward in preparation. Nevertheless, volcanoes retain their mysteries. Not all signals lead to action, and not all unrest is dangerous. The challenge for scientists is to distinguish between routine restlessness and the portent of real change. Monitoring is a shield, but not an oracle. The question of when and how Rainier, or any Cascade volcano, will erupt remains stubbornly resistant to prediction. The region's preparedness is a collective achievement. Local emergency managers, planners, and educators work hand in hand with scientific agencies. For many, Rainier's distant presence is more than scenery. It is a constant prompt to know the routines, the evacuation routes, and the meaning behind each tier of alert. Risk and reality. What's at stake if Rainier erupts? As Earth tremor counts accumulate and scientific fascination grows, the underlying concern remains sobering. What would happen if Rainier erupted? The mountain's unique hazards lie not only in its potential for volcanic explosion, but also in the vast stores of ice and snow layered atop its flanks, the most glacial mass of any U.S. peak outside Alaska. If an eruption were to occur, direct hazards might include localized explosions, ashfall, and lava flows. But Rainier's greatest threat to surrounding communities is likely the rapid formation of lahars. When volcanic heat melts snow and ice, rivers of mud can surge along Rainier's river valley, traveling tens of miles with little warning. Historical mud flows have left distinctive deposits as far away as the Puget Sound lowlands. Could an eruption at Rainier, in concert with sympathetic responses elsewhere in the Cascades, overwhelm the region? The answer is that such a scenario is very unlikely. Each Cascade volcano operates on its own timescale and physical processes. The risk from Rainier is serious enough on its own terms, but the odds of a coordinated multi-volcano disaster are exceedingly remote. Despite the relatively low probability, the impact of a major Rainier eruption could be profound, disrupting infrastructure, filling the air with volcanic ash, and threatening life and property with lahars. Thanks to improvements in emergency readiness, automated warning systems, and rapid response communication, millions are now safer than in the past. Yet, as history and science both remind us, no system is perfect. The mountain's behavior, while better understood than ever before, remains inherently unpredictable. Neighboring volcanoes, watching and waiting. As Rainier captures attention, it is just one actor in the ongoing drama of the Cascades. Throughout the range, every notable volcano is under constant watch. Mount Hood, an imposing Oregon landmark, experiences its own minor unrest from time to time. Crater Lake's deep, caldera-filled basin is the remnant of a massive collapsed volcano. Mount Shasta, Glacier Peak, and the Three Sisters all have their own rhythms of seismicity and gas emission. Of particular note is Mount St. Helens. Since 1980, it has seen periods of dome-building eruptions and remains among the best-studied volcanoes in the world. Its continuous study has helped refine detection methods and advance volcanic prediction science. Less widely known, but scientifically significant, are the more active yet less famous volcanoes peppered across the region. Each exhibits its own personality, from deep, long-period earthquakes to subtle ground swelling. Scientists stress that the region as a whole is never truly quiet. Low-level unrest is a normal part of life in the Cascades. Could Rainier's activity influence these neighbors? Data from past events and the region's geological history indicate such effects would be minor and indirect at best. Shared stress fields or fluid pressure changes might moderately increase earthquake frequencies, but the prospect of one volcano setting off another in quick succession remains in the realm of hypotheticals. Nonetheless, vigilance is the watchword. Scientific and emergency communities are constantly refining detection techniques, running drills, and updating preparation plans. The region's experience is a reminder that even when one mountain stirs, the entire range pays attention, and so should those who call the Cascades home. Enduring mysteries and the power of the unknown. Far above the clouds, Mount Rainier's summit glistens in the evening sun, a seemingly timeless symbol of stability. Yet, beneath that serene crest, the mountain's story and that of the entire Cascade Range remains unfinished, inscribed in fire, ice, and stone. Despite extraordinary technological advances, there are questions the mountains have not yet answered. Why do some earthquake swarms precede eruptions, while others fade quietly? Can subtle subterranean shifts beneath one volcano truly influence another many miles away? Are the tremors warnings or simply reminders that these peaks are alive? What is certain is that the Cascades are not relics, but living features of a restless Earth. Their eruptions, while rare, can be transformative. Their fates, while individually governed, are offerings to the slow but relentless forces shaping the edge of a continent. Mount Rainier, watched more closely now than perhaps at any point in its history, stands as a symbol of both grand power and profound fragility. As we look to these great mountains and ponder the invisible connections beneath, perhaps the truest lesson is not about catastrophic change or synchronized awakening, but about the wisdom of watchfulness and the persistent effort to understand forces much vaster than ourselves. What are the mountains telling us? Are these echoes of ancient eruptions or the prelude to new ones yet to come? Share your thoughts below and join us as we continue our journey through the wonders and hazards of the Pacific Northwest and beyond. Subscribe and turn on notifications for more chapters in the ever-evolving story of our planet's most remarkable landscapes.